This is a lecture from Mrs. Roth's physical science class for Module 9, Week 1. While you watch this lecture, you need to have a copy of your lab report for Experiment 9.1, lab report for Experiment 9.3, and a blank piece of paper for taking notes. You'll also need some scratch paper for doing some sample problems that we'll be doing throughout the lecture. Please note on your assignment sheet that this coming Thursday, which will be now January 19th, you have an assignment that will be due at 3 p.m. We took off last week, so our dates are 1 week off, but it is this Thursday, January 19th, that this assignment will be due on the Learning Link website. Please make sure that you're checking your email frequently until you're told that this is done. I will be teaching in Omaha again all day on Friday, so it may take me a little bit longer to get back with you. So if you can get these turned in earlier on Thursday, I will be checking my email frequently on Thursday, trying to get these back to you as soon as possible. Remember that if you're taking a grace day on Thursday, you need to turn in this assignment on the Learning Link website early, not late. Whenever you take a grace day, please check your assignment sheet for assignments that are due on that day, because you must have them completed on time. Also on your assignment sheet, it informs you that this coming Friday, you may take out all of your papers for modules 1 through 8. You need to leave everything in the other section of your binder. Don't throw anything away. Make sure you put them in a safe place. I recommend just putting a big rubber band around them, and then make sure that you don't ever throw away those binder dividers. You'll want to use those again next year for science. This module is called an Introduction to the Physics of Motion. We're going to begin this lecture by doing experiment 9.3. We're basically going to gather the data for this experiment, and that is what you'll be doing calculations on and submitting on Thursday. So at this point, you want to pause this particular video and switch to the video for experiment 9.3. Now we're going to resume our lecture for Module 9 by reviewing what we've studied so far this year. In modules 1 through 8, we did a lot of different things that fall under the category of weather and meteorology. Even those things fall under what we would say the umbrella of physics. Physics is a very large category of science, and everything we've studied so far this year could technically be part of physics. But unfortunately for us, the physics that we can do right now is just the bare bones because of the level of math that you've had. Science and math, as I say over and over, those things go together. Up until about general science, but definitely in physical science, you could keep those things separated. But now they are going together more, and you're using more math in your science. Most of you should have completed pre-algebra. Some of you are in algebra, possibly geometry. But to really do all of the physics, there's much more mathematics that you would need, such as calculus and other things. And if you continue on in science, you'll need to take those math classes as well. But for right now, we're just going to do what you are able to do with the math that you have completed thus far. So when we think about motion, we notice that all around us we see things in motion. And the study of motion is called mechanics. In mechanics, we are looking to analyze objects in motion. We are looking at the forces that are applied to those objects. And then we are looking at the energy that exists within them. All of those things are part of the study of motion, which is called mechanics. Mechanics 2 is part of physics. So just like weather, meteorology, and mechanics all fit under this umbrella of science called physics. To study motion, we have to start with the idea of position. If the position of an object changes, we know that the object is in motion. That makes sense. If something is in one position and then it's moved to another position, its position has changed and it was in motion while it changed. So, if we have this nice looking young girl sitting at a desk and she has a book beside her, yes or no, is the book moving? Well, what about if we imagine there was the man in the moon? So up on the moon, if you were up on the moon or the man in the moon, would the man in the moon looking down at this girl and the book on her desk, would the man in the moon say that the book is moving? Well, let's back up here. The girl would say that no, the book is not moving. As she looks at the book, it just sits there, it's not moving. But the man in the moon, looking at the book, if you were at the moon, the book would be moving as the earth rotated. So while the girl would say that no, the book is not moving, someone on the moon would say, yes, the book is moving. So how can we have two right answers to the same question? What does that tell us about position? It tells us that position must always be given relative to something else. You can't just say that something is 3 feet away unless it's 3 feet relative to something else. Usually when we say something is 3 feet away, we mean 3 feet relative to where I am. So position must always be given relative to something else. And that something else that it is given relative to is usually called the reference point, a point against which position is measured. So we're measuring that position relative to a reference point. So when we go back to the question of, is the book moving? With the girl as the reference point, it is not moving because the position relative to the girl does not change. So we would say, with the girl as the reference point, it is not moving. But with the man in the moon as the reference point, the position, the distance from the man in the moon or from the moon to the book is changing as the earth rotates and the book rotates with it. So with the man in the moon as the reference point, it is changing. So we come to the conclusion, which is very important in the study of mechanics, that all motion is relative. It is relative to what the reference point is. Thus, the motion of any object depends on the reference point that is being used to describe that object's position. Let's look at another example here. Here we have 4 people, I think it's 4 guys on a ski lift, and I am choosing this second one here as our reference point. So, if he is the reference point, would he say that is he moving? His friend sitting next to him. Now let's assume that they're both sitting still. He's not moving around with his arms or anything. So relative to our reference point, is that boy moving? And the question is, no. The distance between the two of them would be a constant. It wouldn't be changing. So we would say that he is not moving. How about this guy down here on the ski slope? If this ski lift is moving up the mountain, would we say that the green guy on the mountain, is he moving relative to our reference point? The answer there is yes, he is, because the distance between our reference point and the green guy on the mountain, that distance would be changing, and therefore we would say that he is moving. One more here. How about the people down here in the next chair of the ski lift? Would they be moving relative to our reference point? The answer here is no. They technically would not be moving because the distance between the two chairs on the ski lift would not be changing. So we would say that they are not moving, even though everything is moving relative to the reference point. The position is not changing, so those people in that second car are not moving relative to the first car. We're going to stop right here. I'm limited on how much time I can record on a particular video. So we're going to stop this video and you need to continue with part 2.